In this video, let us begin discussing linear functions. And linear functions will make straight lines. So these would be equations of a straight line. And linear functions are often written in a form y equals mx plus b. The form is called slope-intersect because it uses two pieces of information, namely the m stands for the slope, and the slope measures the tilt. So our straight line, how steep up or down or horizontal or vertical, that tilt is measured by the m, which is a slope. The slope is also said to be rise over run, because if we look at what the tilt is, it really tells you how far up one needs to go and how far over to get to the next point. So that's what the rise over run is. It's a slope. The b is the y-intersect. So this is the place where our straight line, whatever it is, so here is a straight line going up, and the b is this number. This is the b. The b where our straight line crosses the y-axis, that's the b. So when we look at the linear functions, there will be four main possibilities. Let's look at each one. So here is the first possibility. We could have a line that is going up. If the line is going up, it has a slope that is positive. A second possibility is we could have a line that is going down, and that would have a negative slope. So this is m is negative. These are the first two kinds, and we will both of these use y equals mx plus b to come up with these diagrams. And the other two are special cases. So this first special case is a horizontal line. That one has slope equals to 0. And the last special case is vertical line, and that one has a slope that is undefined. So m is undefined, that's a 0 with a line through it. That means impossible, cannot be done. So this line actually has no slope. And these are the two special cases, and we will look at how to make an equation of them in the different video. So these two will be done later. So let us try to use the slope-intersect, this formula, to come up with an equation of a line that is going upwards. So here is an example. Let's take 2 points. So here is example. First point is 1, 3, and the second point is 2, 5. Now each point has two numbers. The first number is x, the second number is y. And since we have 2 points, we have to tell them apart. So let's call this first point, and let's say this is second point. That means this is the x from the first point, and that's a y from the first point. That's an x from the second point, and that's a y from the second point. So we use the subscripts to tell the points apart, so that I know that the 3 is the y, but from the first point, and the 5 is the y, but from the second point. So let's make a sketch and use the slope and use the sketch to find the slope. So here is 1, 3 here, and here is 2, 5 somewhere here. And if we connect them, this should make our straight line somewhere here. Missed a bit. But that is what our straight line looks like in real life. Now, can we come up with an equation for it? The first thing, when we look for the equation in the y equals mx plus b form, the first thing to find is the m. So let's find the m. The m measures how far up we go, which is rise, divided by how far over we go, which is run. So how far do we have to go to move from this point to this? That was 2 units. because we are going from the height of 3 to the height of 5. This is 1, this is 2. So if I'm going from 3 to 5, that's 2 units up. So my rise is positive because I'm going up, and it is 2 units. What is my run? Run is always to the right. So how far to the right did I have to go to get from this location to my actual point? And that's 1 unit. From 1 to 2, from 1 to 2 is a distance of 1 unit. So the run is 1, which means I now have my slope. It's 2 over 1, which is 2. And in my equation, I can already replace that information with the 2. So I now have y equals 2x plus b. All I need is the b. The b is the y-intercept, and to find it, all I need is 1 point, and I'm given 2 to begin with, so I can choose any one. Let's choose the first. The first point says that if x is 1, y should be 3. So let's replace them and see what happens. So if x is 1, y should be 3, which means 3 is 2 times 1 plus b. And now we can find the b, because 2 times 1 is 2. And to get to the b, we have to minus 2 from both sides to undo the 2. And that makes 1 equals b. So now I have my slope, I have my b. And that means I have my equation. My equation is 2x plus 1. And that's the final answer for the equation of this line. Let's have a look at it with a calculator. So here is a calculator. We will type in our equation and see if it actually goes through the points that we had. So here was 2x plus 1. We typed it in. And if we look at the graph, here is the picture. Now, the table will show us the list of points. And we can see here is our first point, 1, 3. Here's our second point, 2, 5. So our straight line went through the 2 points that we were given, which means we have found the correct equation of a straight line. Now, this method for using the picture and then counting how far up and how far over works fairly well, but it has its limitations. If I had 1.1 and negative 3.05, placing them on a grid like this and counting will be somewhat challenging. So instead, let us use this example one more time, and let us come up with a formula that will work for any points. And that's the beauty of formula is a shortcut for the entire process. So you no longer have to do everything, you can just plug in numbers. So what do we have? We have here, this 1 was x sub 1, the 2 is x sub 2, the 3 is y sub 1, the 5 is y sub 2. So how did we, our first answer that we obtained was for the rise. How did we get 2 out of 5 and 3? Well, to get the 2, we have to take 3 from 5. Or, in other words, we have to subtract y1 from y2. So I can rewrite my slope as y2 minus y1. That will tell me the rise. That'll count how far up or down I must go. Now, the run was 1, and we got it by counting how far over we have to go using x2 and x1. Well, 2 minus 1 is 1, so if I take x2 minus x1, I will end up with my correct answer. So x2 minus x1 will give me the run. And this is my formula. So this is the slope formula. And from here on, we can now use this formula for any other 2 points, and we will get the slope. After we have a slope, whether it's positive, negative, decimal, whatnot, once we have a slope, the second component is the b, which we solve for the b, and then we're done. So this is the process for finding the equation of a straight line. In the next video, we will begin looking at the 2 special cases, the horizontal line and the vertical line. Thanks a lot for your time. Best wishes.